Yes, sir.
Objective. Introduction of real numbers. Classification of
Virendra, can you hear me? Can you hear the voice of the video? Show me thumbs up like this. Yeah, okay, good.
number sets. Real numbers are extremely useful in everyday life. Speed in general, a numerical value obtained by measuring distance and time. Real numbers help us to count and to measure out quantities of different items. Show the graph of stock prices on NYMEX web page. Weather, air temperature, wind speed, and direction nature. Aeroplane flight tech instruments, altitude, speed. Let's learn more about real numbers. Classification of numbers. In our daily life, we deal with different types of numbers, and these numbers are generally classified into two types, which are real numbers and imaginary numbers. Further, real numbers can be classified into again two types, which are rational numbers and irrational numbers. The totality of rational numbers and irrational numbers is called the set of real numbers and is denoted by R. The set of numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0 is called the set of rational numbers and is denoted by Q. Again, further rational numbers are classified into two types, which are integers and non-integers. Non-integers two types. 1. Terminating decimal numbers, and 2. Non-terminating repeating recurring decimal numbers. Examples: 4 by 5, 2 by 3 equals to 8 by 3, 6 equals to 6 by 1, minus 3 equals to minus 3 by 1, 2.7 equals to 27 by 10, 0.7 equals to 7 by 10, 0.625 equals to 5 by 8, 34.56 equals to 3456 by 100, 0.3 bar equals to 1 by 3, 0.27 bar equals to 3 by 11, 0.14287 bar equals to 1 by 7. Every terminating decimal is a rational number. Every recurring decimal is a rational number. A non-terminating repeating decimal is called a recurring decimal. Between any two rational numbers, there are infinite numbers of rational numbers. This property is known as the density rational numbers. Every integer is a rational number. Integers are classified into two types again, which are negative integers.
Observe one more time, Nana. This is, please see.
Rational number. Integers are classified into two types again, which are negative integers and whole numbers. Finally, whole decimal is called a recurring decimal.
Once again,
between any two rational numbers, there are infinite.
Between two any rational numbers, we have infinitely many rational numbers, right? See, subparts in that here. This is 0 and this is 1. This is 0 and this is 1. Between we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So in that between also, suppose if you take these two numbers, in between them also you have many numbers like this. Okay, even if you take in that also you have many numbers which you cannot count. Okay, right, but we shall find them by using some methods. Okay,
numbers of rational numbers. This property.
See here again, Yeah, between 0 and 1, 10 more lines we have. In that also between, if you take these two blue lines, between them also we have many numbers now, okay?
T is known as the density rational number.
So what is the density of rational numbers? Between two any rational numbers, we have many rational numbers, that is called as density of rational numbers. And if you observe here, see, between 0 and 1, given these numbers, right? So like that, if you take any two rational numbers, we have infinitely many rational numbers. That property is called as density of rational numbers. Density of rational numbers, or dense property, or property of density called. Okay.
Numbers. Every integer is a rational number. Integers are classified into two types again, which are negative integers and whole numbers. Finally, whole numbers are classified into two types, which are natural numbers and a set consisting of zero only. Irrational numbers. Numbers which cannot be expressed in the form of p by q, where p and q are integers and q not equal to 0, is called the set of irrational numbers. Example: root 2, root 3, 3 root 2, 2 plus root 3, root of 2 plus root 3, pi, e, etc. Observation: all non-terminating and non-repeating decimal numbers are irrational numbers. All surds are irrational numbers. Rational and irrational numbers. A. Root 6 into root 7 is an irrational number. B. Root 20 into root 5 is a rational number. C. Root 27 into root 3 is a rational number. D. Root 4 into root 3 is an irrational number. E. Root 32 by root 8 is a rational number. F. Root 44 by root 11 is a rational number. G. Root 18 by root 2 is a rational number. H. Root 25 by root 5 is an irrational number. Summary.
Take the screenshot, Nana. Yes, Nana. Did you get the concept? Yes, Nana. Please, you can raise a hand if anybody is having a doubt. You can raise the hand and ask the doubts. Anybody is having a doubt regarding this video? Yes, Nana. No doubts? Yes, Nana. From KHS, HMHS, MRMS. Anyone can ask. Santosh is laughing. Why? Huh? Yes, Nana. Any doubts? Okay, good. I will choose one student here. Kartikeya.
Sir,
Yeah, can you please summarize what you have seen up to now in the video?
rational numbers, irrational numbers, integers.
Okay. And that's it. That's
Yes, sir.
it. Okay. Uh, one more student. Bhavani, can you please tell what you observed till now in the video? What are the concept he explained?
Sorry, integers, rational number, irrational number. Rational
Okay,
numbers are in the
Okay, continue. Continue.
rational numbers are in the form of p by q, and q is not equal to 0,
Good.
and irrational numbers are cannot in p by q, and q is not equal to 0.
More. That's it. Good, Nana. Very good. Anyway, Sai Anjani, where are you, Nana? Madiha, Shed Madiha. Unmute now. What are the concept you have seen in that video? Any others? Which Bhavani and
Whole number,
no?
the whole number, and the rational, irrational,
Yeah, okay.
integer,
Good.
their examples, their definition.
Nobody is telling you about dense property. What is dense property, Nana? What is dense property? Between the video, I paused that video and explained, right?
Between the rational numbers, so many rational numbers are there, that is called density of rational numbers.
Very good. Hi, Anjani. Can you give any others?
Sir, that only, sir, density of rational numbers.
Okay, other than density property, rational numbers, integers, other than that, did you observe anything?
Other than all that. No, sir, they gave examples. That's it.
Can you give 5 examples for irrational numbers? Unmute now. Unmute.
Sir,
5 examples now for irrational numbers.
yeah, sir. Root 2, root 5, root 7, root 11 by 13, and root 3.
Okay.
Etc. Sir.
Yeah, okay, right, good. And what about in decimal form, Nana? Can anyone give the decimal which are in the decimal form for irrational numbers? Can anyone give? Please raise the hand. Arvani. Vijay. Jarva, unmute, Nana.
Yes, sir.
Yeah, please.
Sir, 2.456, etc.
2.456, etc. Okay, what it means?
We cannot write in the form of p by q.
Cannot write in the form of p by q. Okay, that's good. Very good answer. But make it clear. So we have decimal numbers, remain decimal numbers also, right? Suppose if what is the difference between 1.2 and 1.2, 3, 4, 5, 6, 7? We cannot write in the form of p by q. Even we have a name for the particular name. Yeah, Vijay, unmute now.
Yes, sir, in decimals, 2 type decimal numbers, non-decimal numbers, and in non-decimal numbers, terminating decimals and non-terminating recurring decimals.
Yeah, okay. Wait, Vijay, Raju. Yes, Nana. So Sharwani told that's obviously right, but we have a particular name for that. It is a non-terminating and non-recurring decimal. Non-recurring, right? Non-recurring decimal, non-terminating and non-recurring. It's okay. Good. Any other things did you observe, Vijay? Vijay,
Sir,
did you observe any other things?
sir, about density of rational numbers.
Okay, good. What is density of rational numbers?
So they are infinite of rational numbers between two rational numbers.
We
It is
have
called
infinite
density
number of
ratio.
rational numbers. Okay. Yes, Nana, right?
Yes, sir.
Okay. Very good. Good observation. Right. So next concept is Euclid division lemma. With all of you. Yes, now. Write down the statement. We'll discuss about in the next class. Just write down the statement. Euclid division lemma. Please, you have to refer this topic, Nana. We'll discuss about that in the next class. What is the statement? Given positive integers a and b, there exists unique pair of integers q and r such that given positive integers a and b, there exists unique pair of integers q and r such that a is equals to bq plus r, where 0 less than or equals to r less than b. This is the Euclid division lemma statement, Nana. Yes, okay. So what is the meaning of this? If you take any a and b numbers from an integer set, okay, you will get q and r for that particular a and b. There exists a q and r particular values, and that q and r must be unique. Okay. Other than that q and r, there is no other possibilities is telling, right? So that must be in the form of a is equals to bq plus r and 0 less than or equals to r less than b. See, suppose if I take a is equals to 5 and b is equals to 3, right? And remember, a is greater than b is always, right? Suppose what is the division rule, Nana? Basic division rule. Dividend is equals to divisor into quotient plus remainder. Okay. So if you divide this a by b, which is nothing but 5 by 3, what you get, Nana? Yeah. 3 ones are 3, remainder is 2, right? That we can write dividend. What is dividend? 5 is equals to divisor. 3 into quotient is 1 plus 2, right? Yes, Nana. And 0 less than or equals to what is r? 2 less than 3, right? This is r, this is q, and this one is dividend, and this one is divisor, right? Yes. 5 is equals to 3 into 1 plus 2, and 0 less than or is equals to 2 less than 3. Yeah, if you observe, this is the statement, right? A is equals to bq plus r, 0 less than or equals to r less than b. Is it in that form? Obviously. See here, we have taken 5 and 3, and the existed values are this 1 and 2. For 5 comma 3, you got 1 and 2 are the existing values as q and r, right? Isn't it? And one more thing, this pattern which you are observing here, 5 is equals to 3 into 1 plus 2, we can write in a unique way. We cannot change this order here. We cannot change the pattern. See here, 5 is equals to 3 into plus 2, which gives you the 3 plus 2, 5 is equals to 5, right? You got equal here. Suppose if you change this into 1 into 3 plus 2, okay, this also gives you the same answer. 5 is equals to 3 plus 2, which is equals to 5 is equals to 5, right? Then what is the difference between these two, Nana? What is the difference between these two? Yeah, here divisor is 3 and here divisor is 1. In particularly, it is not obviously right statement because yeah, this is nothing but 5 by 3. 5 by 3 we get this pattern. Then what about this? 5 by 1. Is it 5 by 1? That is also wrong. Okay, as per sentence it is okay, but as per Euclid division lemma it is wrong. Okay, we shall not write this pattern in any other way. That is the only unique way to write. Okay, with the divisor 3. Okay, so what I'm going to tell you is for 5 comma 3 integers, unique pair. Unique pair. What is that? Q and R. Q is nothing but 2 and R is nothing but 1, right? Q and 2 comma 1 existed and 5 is equals to 3 into 1 plus 2, where 0 less than or equals to 2 less than 3, right? Did you get that? See Nana here. So if you observe, we do the division when up to when if the remainder is lesser than divisor, then we can stop the division process there. Okay. So remember, remainder is always lesser than the divisor, Nana. Okay. Remainder is always lesser than the divisor. Yes, remember that thing, Nana. Okay. So that is the this representation note. Okay. Yes, any doubts regarding this? Yes, Nana. Take the screenshots. This one, first paper, second paper, and third paper. We shall discuss about in very detail in the tomorrow's class, Nana. Okay. Yes. Do you have any doubts, Nana? Yes, Nana. Okay. Right. We shall stop here. Yes, Nana. Okay. Bye. I love you. We'll meet you tomorrow. Have a nice day.